boys and girls. Today's video is on comparing fractions using the cross multiply, or also known as the butterfly method. This is a great strategy to use. We've been working with mental strategies such as common numerator, common denominator, one away from the whole, and using a benchmark half. Those mental strategies work some of the time, but this strategy, cross multiply, works every time. I don't consider this a mental strategy because when you have a mental strategy, you're doing that in your head. When you cross multiply, you're showing your thinking on paper, and that's what makes this strategy work. Let's go through some examples. First, I'm going to start by showing you the butterfly method and where this gets its name from. Let's write down two fractions that we want to compare. Say I have the fraction 2/3, and I want to compare it to 4/6. Now, this strategy gets its name, butterfly method, by cross multiplying. Sometimes it's hard for kids to keep track of where they're cross multiplying. And so one way to do that is to circle your numbers that you're multiplying. And cross multiply means just this. You are multiplying this bottom number to this top number, and then this bottom number to this top number. That's where it gets the term cross multiply. But let's look what that means where we get the word butterfly method from. So one way that you can compare your fractions to keep track of what you're doing is to circle your bottom denominator with your top numerator. What is 3 times 4? Well, 3 times 4 is 12. I like to put my numbers up in the top corner pretty small so it doesn't distract you from your actual fraction or your numerator. Now, we're not done. We've only done one step in this method. Let's continue multiplying this denominator by this numerator. To do that and to keep track of that, I can circle those numbers. What is 6 times 2? Well, 6 times 2 is 12, and I'm going to write 12 up in my top corner. And as you can see where the word butterfly method gets its name from, these look very similar to butterfly wings. Now, to finish out this strategy and to finish working out this problem, I have two numbers that I've multiplied. I have a 12 and I have a 12. Well, I can compare those, but neither number is greater than the other. They're the same. So in this case, this would be an equivalent fraction. Now, I like students to use the butterfly method until they don't need it anymore. And I always tell my students that when I teach you a strategy, use it until you know you don't need it anymore. It can get a little messy with all of those cross circlings. It can get messy. I've seen kids cover numbers accidentally, so you have to be very careful with it. I like to cross multiply without the butterfly wings because I think it's much neater and it goes much faster. Let's do some examples. Say I have the fraction 3/8 and I want to compare it to 2/5. Let's cross multiply. To cross multiply, I'm going to multiply my bottom denominator by my top numerator. 8 times 2. Well, I know 8 times 2 gets me 16. I like to put a tiny 16 up in that corner. 5 times 3, denominator times numerator. 5 times 3 is 15. I like to put that in the top corner, very small as I can. Now I've got two numbers. I've got a 15 and a 16. Well, what is greater, 15 or 16? Clearly 16 is more than 15. So when 16 is more, that means 2/5 is greater. That means 2/5 would get 2 dots. 3/8 would get 1 dot, and you're going to connect your dots. Let's do one more example. Erase this one. let's write down two more fractions that we want to compare. I have a fraction 4/10, and I want to compare it to the fraction 3/6. I want to cross multiply, so I'm going to multiply my denominator times my numerator. 10 times 3, that would be 30. 6 times 4, that would be 24. 24 and 30, what is greater, 24 or 30? Clearly 30 is much more than 24, which means 3/6 is greater. So 3/6 gets 2 dots, 4/10 gets 1 dot, and I'm going to connect my dots. 4/10 is less than 3/6. I hope you liked our video on the cross-multiplied method for comparing fractions. I like to tell my class that this strategy works every single time. This strategy is your proof. This strategy tells me that you understand what you are doing and you have proven which fraction is the greater fraction.
2,000 years later.
How to handle a whole number minus a fraction. I had a note about this recently on my channel. It's an excellent question and it needs an answer. Let's take this example. 7 minus 3/5. The easiest way in I can give you here is to say that any number over itself is one whole. Let me show you how that looks. Here's 2/3 and this is 3/3, 3/3. It's one whole. Here's 4/5 and this is 5/5, one whole. Any number over itself is one whole. In our problem, we have to subtract 3/5. Wouldn't it be nice if over on the left, instead of a whole number, we had a mixed number whose fractional part was also conveniently in fifths? Here's what we do. 7 becomes 6 and 5/5. Can you see that this actually represents 6 and 1 whole? And that has the same value as 7. This is going to be easy now. We do the fractional part first. 5/5 minus 3/5, that's 2/5. We don't have any whole ones to subtract here. That's like saying 6 minus 0. The 6 goes straight into our answer. So 7 minus 3/5 is 6 and 2/5. And we're done. How easy is that? Let's do one more, and this time we'll do a whole number minus a mixed number. 20 minus 4 and 5/8. We need to subtract eighths, so our 20 is going to be represented as 19 and 8/8. 19 wholes and one other whole shown as a fraction with that all-important denominator of 8 to fit the fractional part that we're subtracting. Now we subtract fraction part first. 8/8 minus 5/8 is 3/8. And for the whole numbers, 19 minus 4 is 15. And now I think you're ready to rock if you get a question showing a whole number minus a mixed number or a whole number minus a fraction. You got this. Go to it.